laws of motion are the basis of our understanding of physics. Therefore, today I will describe what each law explains, along with a scenario for each law to show you how they work. Let's start with Newton's first law of motion, also known as the law of inertia. Newton's first law of motion states that objects in motion stay in motion and objects at rest stay at rest unless acted on by an outside force. Inertia is the tendency of objects to want to stay in its current state of motion. Here's an example. This is George. One day, he decided to roll a ball on the floor in his living room. Let's assume that the floor here is frictionless. He positions the ball, gives it a small push, and it begins to roll. The ball will keep rolling in the same direction. It doesn't want to change its state of motion and will keep going. This explains Newton's first law of motion because it shows how objects have inertia and don't want to change their state of motion until acted on by another force. So, if the ball hit some kind of barrier, like a wall, the ball would stop rolling, so its state of motion would be changed. The ball stayed in the same state of motion until an outside force, in this case, the wall's force, acted on the ball. Another thing you should know is that the greater the mass of an object, the more inertia it has. For example, in comparison to a tiny ball, our massive Earth has way more inertia, so it has a greater resistance to changes in its state of motion. Next, we're going to talk about Newton's second law of motion. Newton's second law of motion states that the force applied to an object is equal to its mass times the acceleration. This is George again, and this time he's feeling a little adventurous, so he decided to jump off a plane without using a parachute. We'll use this situation to explain Newton's second law of motion. George positions himself, jumps off, and begins falling. When he falls, George exerts a force on the earth. How much is that force? Let's use the formula we just learned to find out. We're not going to have air resistance as a factor in this scenario. The formula is F for force equals m for mass times a for acceleration. George's mass is equal to 46 kilograms, and the force of gravity on George, also known as the downward acceleration, is equal to 10 meters per second squared downward. Therefore, F equals 46 kilograms times 10 meters per second squared. This turns out to be equal to 460 newtons, the unit for force. We just used our newly learned formula to find out the force George exerts on the Earth. Don't worry, he's okay. Finally, we're going to discuss Newton's third law of motion, which describes how every action force has an equal and opposite reaction force. So, when object A exerts a force on object B also exerts a force on object A that is equal and opposite in direction. Here to explain this is George again, and this time he's sitting on a chair. When George sits on the chair, he is exerting a downward force on the chair. This is called the action force. In reaction, the chair exerts an equal upward force on George. This is called the reaction force. Forces work in twos, where there is one action force and one reaction force. That will be all for today. I hope that you enjoyed this video, while also being able to understand Newton's 3 laws of motion. Thanks for watching, and you'll be glad to know that no stick figures were harmed in the making of this video. It's all just for science anyway.